Well, get your fucking head out of the fucking ass and think about it. Now everybody's talking about the big fucking money, right? Well, the big fucking money doesn't help you a lot today, right?
Hello, what's up YouTube? Welcome back to another episode of I Make Free Energy for you guys on YouTube. Yes, my suggestion and recommendation is stop going to school. Yes, 2017. Stop receiving a formal and real education. Oh yes. Nowadays we have YouTube, internet that can offer all the knowledge you need. Of course. Yeah, let's take a look at this video.
But no one can explain when you turn the switch of their house on, the light comes on, why it all happened. It's a big fucking mystery. And we've been looking for the mystery for 100 years. But no one want to show you or want to tell you how they actually do it in a power plant.
Did you see that? Did you hear that? When we switch the line on and off, we really don't know what happened. It's been a mystery now for over a century. Power companies and power plants are really hiding from us their switching mechanism. When you switch the light on and off, it's a mystery. Power companies don't want to show us how the switching gear takes place in a power plant. Okay guys, let's go together watch these beautiful and informative videos about switching gear, power plants and power companies. Thank you guys for watching.
us to Greenwood, South Carolina, where we will visit Eaton, who manufactures medium voltage switchgear, a vital part of the smart grid. Wow, that was fast. Here we are in Greenwood, South Carolina, at Eaton Electrical's switchgear plant, where today we're going to learn about switchgear and how it's manufactured. But more importantly, what is a switchgear? So, let's go take a look.
The switchgear basically is similar to panel board, except it's a large switchboard designed to handle very high voltage and high currents. It is used in large industrial facility. It's used in wastewater treatment plants to control, turn on and off large motors. It's used in a power generating station to turn on and off many loads. It consists of a switching device such as circuit breaker or a switch. It includes measuring devices such as current and voltage transformers. It includes protection and control devices such as relays, and then it includes conductors such as buses and connections to carry the power from point A to point B.
How much power can this thing handle?
This switchgear typically is applied at voltages 2400 volts up to 38,000 volts.
Wow.
And it can carry currents from 1200 amps to 5000 amps.
Where will we see a switchgear out in the real world?
It could be in switchgear assembly at the substation at the university campus. In the university campus, you have different buildings, labs. Utility is not going to supply power to different buildings and different campuses. They bring power to one location. And the switchgear from that location supplies power to all these different buildings. So it can control the flow of electrical power more efficiently.
Tell me about the assembly process for switchgear here in Greenwood.
All right, we start in our fabrication department with copper and steel pieces. We bend, punch, pierce, and form both copper and steel. Then the copper parts are sent across town to our epoxy coating department, which is a insulation process we put on the copper bar. The steel parts are then progressed on through our welding department and then into our powder coat department. After we fabricate the parts, concurrently we're also building sub-assemblies for the gear that we're building. So we have sub-assembly departments that entail producing bottles, pans, drawers, pre-paneled wires, and doors. And the idea is to have all of our sub-assemblies, our steel and our copper components ready. So when we get into our lean assembly process, we can start pulling these components in as needed and build the process through our lean operation up into final assembly and test and then on to shipping. Quality assurance is very important for us. We can run into issues both internal with poor quality parts that need to be rebuilt or reworked for the customer. If something of poor quality gets outside of our operation to the customer, could result in shock or possible electrocution or death to a customer.
So I would assume safety is the #1 priority here during your process, including the line workers.
Right, both safety and quality are #1. We strive for a culture of zero incidents, which essentially is we do not want anybody getting injured here or outside based on our processes. And then a culture of zero quality means we have zero defects in the operation.
The emerging smart grid requirements that is very prevalent in the industry right now has really driven us to use more microprocessor-based solutions in the relays and meters. Those products allow you to capture a lot more information that can then be fed back and enable you to more intelligently turn your loads on and off, which really is what smart grid is driving for. Just understanding more what your system is doing and being able to react accordingly based on the conditions that you are seeing.
Switchgear is going to play a vital role in this alternative energy options that we're seeing today with wind and solar. The energy has to be converted in both cases from wind or solar to a usable electric energy source. In both of those cases, we've got to have means of having power flow in both directions. We've got to know when the power is essentially being used to put back onto the grid versus turning it off when the solar or wind generation is not there. It's going to be the main artery. To distribute the power, to determine the power flow direction in terms of it being backfed from an alternative source versus the power plant, or distributing power from the rectifiers and inverters and other pieces of equipment that will be required to make this a usable form of energy.
Actually, pretty much everything we make here is engineered to order. It's very rare that we manufacture the same lineup of switchgear twice. The reason for that is every customer has different needs and wants, and we try to tailor the product to exactly what they want. We're consistently working on new technology, coming up with new products that we think our customers are asking for. We get that by talking to the customers and getting their feedback on what we have and what they want. We think to continue to be a leader in this industry, we're consistently looking for engineering talent to come in and bring in a fresh perspective, fresh ideas that can help, drive some of the new technology that we want to come out with.
Right out of college, inside Eaton you have a lot of options. That's what this company has. It has a lot of distributions and it has a lot of divisions. Eaton gives you choices. You want to be an application engineer, you want to be a software engineer, whatever you want to be, Eaton will support you completely. Eaton does not only give you a job, it gives you a career.
Our objective today was to learn a little bit about switchgear, how it is made, and the role it plays in the smart grid. I also wanted to give you an idea of the many types of engineering disciplines that go into the making of state-of-the-art electrical equipment. From Greenwood, South Carolina, and Eaton Electrical, I'm Bobby Balicki.